The objective of On Pylons is to develop the ability to maneuver the airplane accurately while dividing attention between the flight path and selected pylons on the ground. On Pylons involves flying the airplane in circular paths, alternating left and right, in the form of a figure 8 around two selected pylons. No attempt is made to maintain uniform distance from the pylon. The airplane is flown at such an altitude and airspeed that a line parallel to the airplane's lateral axis and extending from the pilot's eye appears to pivot on each of the pylons. During pre-flight, you will first need to determine your pivotal altitude for the day by using the equation ground speed squared divided by 11.3. That answer should then be added to the approximate field elevation over which the maneuver will be performed to find your final pivotal altitude. Some pilots prefer finding two pivotal altitudes that correspond to their fastest and slowest ground speeds for the wind that day. These two altitudes will define an envelope in which all other pivotal altitudes will fall between throughout the entire maneuver. When ready to perform the maneuver, conduct two 90-degree clearing turns and use the B-GUMP acronym for setup. In the aero, boost pump will be on, gas will be to the fullest tank, gear will remain in the up position, select mixture rich, and set the propeller to 2400 RPM. Finally, trim the aircraft for 110 knots prior to entering the maneuver. Before entry, select 2 points about 3 to 5 seconds flying time apart, which are on the ground along a line which lies perpendicular to the direction of the wind. Ensure that the points allow for the maneuver to be performed clear of obstructions and populated areas. It is very important that the pilot allow for an entry of 45 degrees diagonally crosswind at the midpoint between the two pylons right at the pivotal altitude. This way, the aircraft is beginning the first turn into the wind at its highest pivotal altitude. The wing should maintain level until just prior to the aircraft reaching directly abeam the point on the ground. As the wing moves forward to meet the pylon, the pilot should lower the upwind wing to place the pilot's reference line directly on that pylon. Use a reference on the wing exactly 90 degrees to the pilot's eye to determine where the line of reference will lie. Once this reference is determined, the wing should appear to pivot directly about the pylon as though attached by a taut rope. As the aircraft continues the turn, ground speed will decrease, and because of this, it will cause the pivotal altitude to decrease as well. Therefore, the pilot will have to pitch down slightly to match a constantly decreasing pivotal altitude. In this case, the stronger the wind, the more aggressive this control application will have to be to maintain the pivotal altitude. During the first half of the turn into the wind, the pilot now must make smooth corrections in pitch to maintain that wing on a rope visual reference with the pylon. At no time should the pilot attempt to maintain the visual reference by using rudder to sway the wing tip back and forth. Rudder should only be used for coordination purposes. Once the aircraft finishes the first half of the turn and passes through a direct headwind, ground speed will begin to increase and the pilot must begin to smoothly pitch back in order to constantly match the increasing pivotal altitude. Understand that as long as the pilot can maintain that pivoting reference line during the entire turn, the pivotal altitude will be maintained as a result of having the wing right on the pylon. If the wing begins to move ahead of the pylon, the aircraft is drifting below the pivotal altitude and pitch must be increased. If the wing tends to move behind the pylon, the aircraft is moving above the pivotal altitude and the pitch must be decreased. The name of the game is anticipation, and the pilot should recognize variations in reference immediately and then correct accordingly. The pre-calculated pivotal altitudes are only being used as a beginning and a midpoint reference. Although maintaining an equal radius around the pylon is not a requirement of the maneuver, having an equal distant entry radius does make the maneuver easier to perform. Picking an aiming point approximately a third to a half mile downwind from the selected pylons will give the pilot a point to track to both during initial entry and after completion of the first turn. This will avoid difficulties encountered when a pilot errs on the entry angle or errors in judging when to roll out of the first turn. As the first turn is completed, take care to roll out on an opposite 45-degree line that will track directly to the second aiming point and correct for wind drift. During this transitional phase, take care to scan the area for traffic as the second pylon approaches. This next turn will involve the same control techniques as in the first, except that now the pilot will reference the opposite wing on the pylon. Rollout will consist of simply returning the wings to level and resuming coordinated cruise flight at the completion of the second turn. The commercial PTS requires that the pilot determine the approximate pivotal altitude while also selecting suitable pylons prior to entry. Bank should be 30 to 40 degrees at the steepest point, and the pilot must apply the necessary corrections to maintain the line of sight reference on the pylon. Finally, the pilot must divide attention and avoid using slips and skids to maintain the pylon. For more information on 8s on pylons, reference the Airplane Flying Handbook, Chapter 6, and the UND Aero Standardization Manual, Chapter 3. Have fun and fly safe.